everyone, how are you all? I hope you all are doing wonderful. So as you all know that I have started with the JEE Main PYQ sessions, and in each of the sessions I am discussing each and every topic of mathematics on which I am solving basically the top 10 and top 15 important previous year questions, which can guarantee definitely the same concept will get repeated in your JEE Mains examination. So if you are someone who has started watching these particular sessions from this particular video, I would request you to go to the description box of this particular video and you will find a playlist and start watching the videos from the beginning. I have already covered coordinate geometry and started with the algebra portion on which I have covered quadratic equations. And today's topic will be basically complex numbers. So today's goal is the PYQ sessions 7 and we will be covering complex numbers. And today's goal will basically to solve top 10 important previous year questions on the topic of complex numbers. Alright, so if you have been following me for quite a long time, you must know the code of conduct. So whenever you get a question, just pause the question at this particular moment and try that particular problem by yourself. Afterwards, tally yourself or grade yourself on the basis of +4 for the correct ones and -1 for the incorrect ones. And definitely comment me in the comment sections. I'll be eagerly waiting for your comments. With this, let's get started with the very first question. And the very first question is on the screen. So go on, pause the video and start solving the question on yourself. The question, it says that if the set, so it is a set where the real value of this particular complex number, okay, so there is a complex number such that z belongs to a complex number, and the real part of that particular complex number z is equal to 3. So I can definitely write complex number as alpha plus I times of beta, where I, or you call it iota, is basically square root of -1. Now then, and if it is said that the real part of z is basically equal to alpha and that is equal to 3, so I can definitely write z as that 3 plus iota, okay, and I can definitely assume beta or some as y, okay, that's my choice, okay. And if I say that the complex number z is of this particular fashion, so let us assume the complex number is equal to 3 plus iota into y. Now it is said that in the set the real value of z minus z bar plus zz bar, okay. Now if you know zz bar is basically a property that zz bar is equal to mod of z whole square divided by 2 minus 3 times of z plus 5 times of it is z bar, okay. What does bar here denotes? It basically means conjugate, okay, conjugate of complex number, conjugate of complex number. That means z bar here will be basically equal to 3 minus iota times of y, so that will be basically 3 z bar. Now let us assume that inside this particular bracket whatever complex number is given, let us assume as z1, so the complex number be z1. So if I assume this particular complex number as z1, now let us go on solving for z1. So z1 I can write it as, it is basically, so if I for example I know this particular value, that is z minus z bar is basically equal to, so for in place of z, and you can definitely remember this particular properties, that is z plus z bar and z minus z bar. So if you consider z plus z bar, that basically will have the negative part will get cancelled and this will be equal to 2 times of alpha, that is 2 times of real part of z. And similarly z minus z bar is basically 2 times of imaginary part of z, that is 2 times of iota times of beta, okay. So in this particular case the z1 for z minus z bar will basically equal to 2 iota times of y plus, and zz bar is basically equal to is equal to mod of z whole square. Also you know this property, that is zz bar is equal to mod of z whole square, and we know that mod of z whole square is equal to, so 3 plus iota y as the modulus value, square of the modulus value will be basically equal to 9 plus y square. So I will put over here, this is 9 plus y square and whole divided by 2 minus 3 times of 3 plus iota y plus 5 times of 3 minus iota y. So that is z1, and if you simplify, you can definitely simplify it as 9 plus y square plus iota times of 2y whole divided by, so if I write this and then whole divided by, you can definitely simplify this. So here 2 minus 9, so it will be -7, -7 plus 15 is basically 8. So 8 over here for the real part, and the complex part will be basically, and if you solve the complex part, this is 3 and this is 5, that is minus of 8y. So that becomes the denominator part. and you can definitely rationalize this as, okay, not rationalize, you can basically like you can multiply with this conjugate, okay, the concept that you basically use for rational number to convert irrational numbers, okay, and that is the rationalization. Similar concept you can apply over here, and that is basically the concept of converting into this particular complex number into a real number, so that the division is simple, okay. So with that, I can definitely write this as, okay, this is 8 times of 1 minus iota y, and the numerator part is 9 plus y square plus 2 times of iota into y. Now I can definitely multiply with this conjugate. So, or since I need the real values of z1, therefore the real value of z1 and multiplying with this conjugate, it will definitely imply the value will come out as. So if you multiply with 1 plus iota y, and in the numerator as well, so the denominator will become 8 times of 1 plus y square. So the real part of z1 will have the denominator as 8 plus 8 times of 1 plus y square, and similarly for the numerator part, multiplying with 1 plus iota y, so it will definitely become, so you can definitely it will become 9 plus, so this particular part will come out by multiplication of 1. And similarly we just need to look for the real part, okay, we don't need to write the entire now z1 by multiplying with this conjugate, rather we look for only the real part, and that will become, and from here the iota y, and with 2 iota y it will become, it will definitely become minus of 2y square, okay, so it will become as minus of 2y square, okay. So that's basically the real part. So we got the real part of z1, okay, the z1 that we basically assume, we got the real part, and it is saying that the real part, so basically it is basically the set which is talked about in the problem is basically of the real part, okay. So the real part of this particular z1 complex number is equal to basically of the interval alpha and beta in closed interval and alpha in open interval. So I have to look for alpha and beta, so let us do so. All right, so let us try out, and what if we see the real part of z1, we observed it as, we basically got it as 9 plus, okay, sorry, 9 minus y square whole divided by 8 into 1 plus y square. Now what I can do, I can definitely simplify this result as, so I can in the numerator part I can write this as 10 minus of 1 plus y square. Now why did I do so? Just to get to the interval, okay, easily. We will definitely understand if I cancel 1 plus y square and the 1 plus y square in the numerator denominator, it will just become a simple number, and then I can be easily be taking out the what is the interval. All right, so with this can also be written as 1 by 8 times of 10 by 1 plus y square, okay, minus of 1, okay. I can definitely write this as like this particular fashion, and what I can understand that if since the z is basically a complex number, that is 3 plus iota y, where y is basically a real number, okay, that means 1 plus z square will be 1 plus y square will be obviously belonging to 1 to infinity with 1 in the closed interval. All right, so you can definitely write this as 1 by 1 plus y square will have the interval that is 0 and 1, okay, 1 in the closed interval and 0 in the open interval. So this will have the fashion, and if I multiply with 10, so it will also be like multiply with 10, that means 10 times of 1 by y square will have the interval 0 to 10. And similarly if I subtract 1 from here, so if I subtract 1 from here, it will have the interval minus 1 to 9, 9 in open and 1 in 1 in open and 9 in closed. And now I just have to multiply it with 8. I have to multiply this whole particular value with 8, okay. So therefore it will belong from minus 1 by 8 to 9 by 8, 9 by 8 in closed and minus 1 by 8 in open. That means this is alpha and this is beta. So if I have the values of alpha and beta, I can definitely I can definitely find out the value of the expression 24 times of beta minus alpha, and that is equal to 24 into, so 9 by 8 minus of minus 1, that is 1 by 8, and that is basically equal to 10 by 8 into 24, so this is basically equal to 30, and from here you will get the answer to this particular problem as 30. So if you have solved this particular problem and your option is option number D as the right answer, then you basically obtained a plus 4 marks. So I hope this particular problem was fairly simple, but it is very important problem, because if you look at the previous year problems, you will definitely encounter this similar kind of conceptual problems in many papers. Okay, so if you look at different shifts or the attempts, you will find that these types of problems actually get repeated. So that is the motto behind taking this particular problem. I hope you will understand this particular problem. With this, let us move to the next problem, and the next problem is on your screen. So again, pause the video and try out this particular problem on yourself. Alright, this is quite an interesting problem, to be honest. So let us try this particular problem. Alright, so the problem says that there is a set S, and the set basically consists of the Z which belong to a complex number such that conjugate of Z is equal to iota times of Z square plus real part of Z bar, that is a conjugate of Z. So real of conjugate of Z is equal to real part of Z, and that is very true. Then it is basically asking you for all the values of Z which basically belongs to the set S. You just have to sum up for all the values of Z, that is modulus of Z whole square. Alright, so let us understand how to solve this particular problem. So since you will look at the complex number problems, you will not get a lot of information regarding complex number problems, but after all, you just need to start the problem by assuming the Z as sum x plus iota y. So that will be the basically what to say, is basically the first step, like how to solve this particular problems. Okay, so whenever you don't get any idea how to solve the complex number problem, just assume Z as x plus iy, and then put the x plus iy in the corresponding complex equation and definitely solve for x and y separately, and therefore you can definitely get to the conclusion, and that will really help you. So with this, let us assume, so let us say that z is x plus iota y. Okay, x plus iota y. Now it is said that I have to look for the set for set z belonging to complex number, and it is satisfying the condition that is modulus of z is equal to iota times of z square plus real part of mod z bar. So if you look at this particular expression, you can definitely write modulus of z bar is basically x minus iota y is equal to iota times of, now z square will basically be equal to x square minus y square plus 2 times of iota y plus real part of z bar is basically again equal to x. So that's the entire thing, and from here you can definitely compare the real and the imaginary part. So on comparing the real part, okay, comparing real and imaginary part. Okay, so if I compare the real and imaginary part, real part is x, so x is equal to, so if I compare the real part, so that will basically iota into 2 iota y, and that will become minus of 2y. So that will become minus of 2y. So you can definitely, sorry, there is a x missing out from here. I forgot to write x. Okay, just you need to multiply with x and y. Okay, because there is z square, right? So x into y. So this will be minus of 2xy, and from here you will obtain an equation that is of the format. So if you take it on the left hand side, you will get, and then take x as common, then you will get the equation as 1 plus 2y is equal to 0. So from here two conclusions are basically obtained, that one is x is equal to 0 and other is y is equal to 1 by 2. Okay, so both of them can be equally likely. Now let us look for, so this is the first equation that is basically obtained, and the second, on comparing the, okay, for imaginary part. So if I compare the imaginary part, okay, so if I compare the imaginary part, what I will get? So I will get it as minus of y is equal to x square minus y square, and the last part will be equal to plus of x. So that's the value that is equal to, and if I solve this equation, this will be x minus y. Okay, so you can take this on the left hand side, then minus of x minus y is basically equal to x square minus y square, and you can definitely write x square minus y square as x minus y into x plus y. Okay, so from here you will again get two values. Okay, that is x minus y basically get cancelled. That means one value of x minus y is equal to 0, and other value of x plus y is equal to minus 1. Okay, so let us form some cases and let us solve this particular problem. So the very first case I'm writing over here, so the case 1, okay, where x is equal to 0. Okay, so the case 1, if x is equal to 0, then minus of y is equal to minus y square. Okay, minus of y is equal to minus y square. So from here two values of y are possible, that is 1 and 0. Okay, so since it's a quadratic equation, so it will have two values 1 and 0. So if x is equal to 0, then y is basically equal to 1 or 0. and similar, that means the possible values of z is basically 0 and one of them is iota. Okay, so these are the possible complex number which basically belongs to the set when x is equal to 0. And similarly, let us consider for the second case, the case 2, when y is equal to minus of 1 by 2, and when y is equal to minus of 1 by 2, I can write this as 1 by 2 is equal to x square minus 1 by 4 plus of x. Okay, so from here you will again get a quadratic equation. So you can see the quadratic equation is x square plus x minus of 3 by 4. Okay, you can take this on this right hand side and equate it to 0. So minus of 3 by 4. So if you solve this, 4x square plus 4x minus 3 is equal to 0. So from here the roots were basically obtained as, so you can factorize this as, that is, the factorization will be something as 2x minus 1. Alright, so 2x minus 1, and the other factor will be 2x plus of 3. Alright, so you can, yeah, it is true. Okay, and from here, exactly, it is true. Yeah, so from here you can get the roots as x is equal to half and other root as minus of 3 by 2. Alright, so from here the possible complex numbers are, that is, z is equal to half minus half iota, or it can be minus of 3 by 2 minus of half iota. Okay, so there are the possible complex numbers. Now just have to need for the values of summation where z belongs to the set S. I have to find the mod of square of the modulus value of the complex numbers, and if I do that, first value complex number is 0, second complex number has a modulus value 1, so 1 whole square is 1, and then this particular complex number modulus has 1 by 4 plus 1 by 4, that is 1 by 2. Okay, and similar this value is 9 by 4 plus 1 by 4, that is 10 by 4. Okay, so you can definitely write this as 2 by 4. Okay, and that is 3 by 2 plus 10 by 4, that is 5 by 2. So 3 by 2 plus 5 by 2 is equal to 8 by 2, and that is equal to 4. Okay, you can definitely solve this and get the required answer as 4. So with this, the right answer to this particular problem will be option number B. I hope you have done this particular correctly, and you must have go on tally with your answers and my answers. All right, so you can definitely obtain easily a plus 4 over here. So I hope this particular problem is clear to all of you. With this, let us move to the next problem, and the next problem again looks fairly simple. Okay, but it has some conceptual problems including it. Okay, so if you have studied the geometry part of the complex number, then you must be able to solve this particular problem. If not, you can also try out this problem on the basis of the concept that I basically gave you, that is identifying that z as x plus iota y, and definitely proceed the question on based of that. So let us do so, and basically let us see that it is saying that let C be the circle or in the complex plane. So a circle in the complex plane with a center z0 and the radius r is equal to 1. So that is basically, well, you know that this particular concept, that is, you can convert any complex number as a basically as coordinate x comma y. Okay, so that's the beauty that you can definitely look for. So whenever you talk about question of a complex number, you can assume that a question of a coordinate geometry, or also if you talk of complex numbers, you can definitely assume that particular concept to be a concept of vectors. So that means that you can relate 3 chapters in together. Okay, so with this, let us see. So if I say that there is a circle with the center as z0 and the radius is 1, and let z1 be the complex number, let 1 and the complex number z2 be outside the circle. So z1 and z2 be outside circle such that z1 minus z0 and z2 minus z0, both of the distances multiplied with both distances are multiplied. Okay, so z1 is basically a complex number which is basically lying outside the circle, and if it is distance taken from the center, and the secondly z2 whose distance taken from center and then multiplied, that the product is equal to 1. So if it is said that z0, z1 and z2 are collinear, that means they basically lie on the same straight line, then you have to look for the smaller values of mod of z2 whole square. This is a good question. Okay, so let us see what is z0 is. So z0 is equal to half times of 3 by 2 iota. Okay, that is the value of z0, and z1 is equal to 1 plus iota, and z1 is equal to 1 plus iota. Now let us calculate z1 minus z0 modulus. What is the distance between z1 and z0? And if you look at this, if you calculate z1 minus z0 is half plus, okay, sorry, minus my 1 minus 3 by 2 is basically minus of 1 by 2, and if you find this distance will come out as, so root under 1 by 2, and that is root 1 by root 2. So if you calculate this distance, you can definitely do it on yourself. Okay, This is a fairly simple calculations. Okay, and this will come out as 1 by root 2. And now what is asked in the problem? It is also given, that is the product of the distance, that is z1 minus z0 mod and z2 minus z0 mod, and multiplied them, the value is equal to 1. So from here you will get z2 minus z0 modulus is equal to root 2. Okay, you can just cross multiply and you will get it as root 2. Now what I will do from here, then there is a very crucial step involved, that is, now it is said that also z1 and z1, z2 and z0 are basically collinear. Now I will use that particular concept. Now before doing so, let me write that z2 minus z0 divided by z1 minus z0. So what basically this implies, if you can definitely understand, this is basically the talking of like concepts of slope. Okay, or if you look for that the value, the what is the equation of a straight line in a complex number. Okay, so in a complex fashion, what is the equation of straight line? All right, so if you know the concept, that is the concept like how do you multiply with a multiple and you get to that, so you can definitely do so. Or you can also apply the principle that is known as the rotation of a complex number. So for example, there is a complex number and the center is z0 and z1 is a complex number, and this particular complex number is rotated by some angle theta. Okay, by some angle theta, and you have to look for z2. So you can definitely write z2 as, you can concept of that particular concept that I'm basically applying for, I'm trying to teach you. Okay, so this concept is basically like you just multiply z2 minus z1 divided by modulus of z2 this, and is equal to z1 minus z0 divided by modulus of z1 minus z0, and into what is the angle by which it is multiplied. You just multiplied with that particular angle, that is theta, and theta should be in radian. Okay, how does this concept act like? If you look at this complex number and write this as r into e to the power theta, and this is value is phi, so you can definitely write this as r into e to the power theta plus phi. Okay, and then you can write e to the power theta into e to the power phi, and e to the power theta is basically equal to this particular complex number into e to the power phi is basically the multiple angle. So this will be e to the power the angle by which it is rotated. Okay, the e to the power the angle by which it is rotated. For example, it is rotated by angle phi. Okay, and that's how basically get to the rotation of any complex number. Now similarly, so for straight line, if the rotation is like of the multiple of 0, pi, 2 pi, okay, like that, and you can definitely achieve the particular condition. Okay, so from here you can definitely write this particular value is equal to z2 minus z1 mod divided by z1 minus z0 mod into, and if it is basically, if the angle is 0, so you can write this as plus minus of 1. Okay, and similarly the value will be equal to, so this value is equal to root 2. Okay, and this particular value is equal to root 2, and this is value 1 by root 2. So 1 by root 2 by 1 by root 2 is basically 2. So 2 into plus minus 1, so the value will be coming out as plus minus 2. Okay, now from here you can also write this, the conclusion you can write over here is basically z2 minus z0, this is not mod, this is equal to plus minus 2 into z1 minus z0. You can definitely write this as like this particular value. Okay, so from here you will write z2 as, okay, from here you can definitely write z2 as z0, okay, z0 plus minus 2 times of z1 minus z0. And if you solve, and now you know the values of z1 and z0, and definitely solve for z2 by one putting plus value, and other time you put the minus value, and you will basically get two complex numbers which are possible for z2. So if you solve for the plus values, okay, that is 2 times of z1 minus of z0, also also the other possible values, and if you calculate this value, also this particular value will come out as, like you can calculate this as 3 by 2 plus half times of iota. So from here the modulus of square of the modulus value is equal to 5 by 2. Okay, so 5 by 2 is the value, and similarly if you take the minus sign, the value will come out as 3 times of z0 minus 2 times of z1, and if you solve this particular complex number, this will come out as minus of half plus 5 by 2 iota, and if you compute the modulus value whole square of this particular complex number, this will basically equal to 13 by 2. So from here the question it is asking for the smallest value of the z2 mod whole square, that is equal to 5 by 2. So which is option number B is the correct one. So I hope you have solved this particular problem on yourself and you got to this particular answer as option number B. So only thing that was wonderful of here is basically this particular step. Okay, this particular step. Okay, like multiplying with plus minus 1, because for example, if you think of the number like this, so if it is z0 over here, z1 over here, and z2 over here, then you basically consider as a plus 1 plus sign. And similarly, if the number is on the other hand, then this particular z2 is also possible. So two possible values of z1 z2 is possible. So like this or like this. Okay, unless and until it is basically mentioned in which z2 is to be considered. So that's why we have to basically find for the smaller value. The question is saying is to find both the z2, and then once you find both the z2, find the modulus value of z2, and which of them is smaller, you represent that in the answer. So I hope this particular problem was clear. All right, so that's a pretty simple problem, fairly simple problem. All right, so with this, let us move to the, because it has geometrical implication, I took out this particular problem just to make you understand that geometrical problems are also asked in the examination. But you don't need to worry about and remembering lot of formulas. Rather, you can definitely ace this problem easily. Okay, so with this, let us move to the fourth problem, and the fourth problem is on your screen. So you can definitely, this is basically a statement types of problem, and a fairly simple problem. Okay, if you look at the statements, okay, the very first problem statement, and I can definitely think of like giving this particular problem as a homework problem, because this is a conceptual problem, and I want all of you to give your mind or idea on this particular problem. Okay, but I will definitely give you a hint like how to basically approach statement types of problems in an examination. The very first thing to approach statement types of problems in an examination is just to look for the options. Let us first study the options, and then you basically talk of. Okay, so it is saying that A belonging to the complex number C, such that the set A, basically set A and the small a is different. The set A basically belongs to all the z, which is basically complex number, such that the real part of A plus modulus of, conjugate of z is greater than imaginary part of conjugate of A plus z. Okay, so you have to look for this. This has geometrical implications. So if you are not getting how to start, you can definitely start like this particular fashion. That is, firstly assume A as some alpha plus iota beta and z as x plus iota y. Okay, and if you do so and then put in this particular values, you can definitely find there's a real part of, that is real part of A plus mod of z, and mod of z, if you look at the real part will be x alpha plus x, and it is greater than the imaginary part of not mod, it is conjugate of A. So conjugate of A is minus of iota beta, we'll have the imaginary part as minus beta, and plus that is y. So this will be y minus of beta. Okay, and you will find that there is a relation that now A is basically a constant value or a constant complex number. So from here you can definitely get x minus y is greater than minus of alpha plus beta. Okay, minus of alpha plus beta. So this will basically imply a region or inequality. And similarly, if you look at the statement 1, it is saying that for if real A, imaginary A is both of them are positive, then set A contains all the real numbers. Then set A basically is basically this particular value. So if A and real part and imaginary part of A is positive, that means the x minus y is basically greater than some negative value. Okay, because both of them are positive, so definitely the sum is also positive, and then minus of sum positive is basically a negative number. That means x minus y is greater than a negative number. So let us first plot what will be the equation. So if I look for the minimum value of alpha plus beta, since both of them are positive and greater than 0, so this will be greater than 0. Okay, so that is x minus y is basically x minus y greater than 0 will be of this particular fashion. Okay, and then the constant values, you can definitely imply some constant values and definitely get that this particular region it is basically implying for. Okay, and definitely you can solve this on your own and definitely understand that the set A actually contains all the real number or not. If it is basically above the in the positive half of the y-axis, okay, you can assume that you just have to need to consider that all the real values, that means basically it will have its all the values on the this particular x-axis, and if it has all the values on the y-axis, it is purely imaginary. Similarly, if it has purely real, then basically it will lie on the x-axis. Okay, but it doesn't satisfy that, therefore I can say the statement 1 is false. Okay, so this is false statement. Similarly, you look for the statement 2. Okay, so I hope you can do this particular problem on yourself as well. Okay, and definitely comment me in the comment section what is the answer with your concepts, with your logic, in the comment section. I'll be waiting for your comment. So definitely, okay, so comment below. So definitely comment. Okay, I'll be looking for your comments. All right, so with this, let us move to the fifth problem. Alright, so the fifth problem is again an interesting problem which basically has a geometrical implication, that is the rotation of a complex number. Okay, so let us try to solve this particular problem. So it is said that in the problem that W1, so it is said in the problem that W1 be a point obtained by the rotation of Z1. So Z1 is a complex number that is equal to 5 plus 4 times of iota about the origin. So if it is rotated about the origin through a right angle in the anti-clockwise direction, okay, you basically get the complex number W1. And similarly, W2 is the point obtained by the rotation of Z2, that is 3 plus 5 iota about the origin through a right angle in the clockwise direction. Then the principal argument, you have to look for the principal argument of W1 minus W2 is equal to what? So let us firstly find W1. So if you look at Z1, okay, you can definitely take help of this geometrical implication, that is X means the real part of Z, and similarly the y-axis basically implies the imaginary part of z, and the sum z1 is something a complex number which is a dot, okay, sum like this 5 plus 4 iota beta. So if it is rotated about the origin, so if you connect this from the origin, so this is the complex number, and if you rotate it about the 90-degree angle, okay, so if it is rotated through a 90-degree angle and the W1 is therefore becomes equal to this, and this angle is 90 degree, so we can definitely use the concept of, that is the rotation of a complex number, rotation of complex number. So I'm using the concept of rotation of complex number. Okay, so if I use the concept of rotation of complex number, I what I will get, so from here I will get it as z1 divided by modulus of z1 into e raised to the power pi by 2 is equal to the final number, that is w1 minus 0, because it is origin, so with respect to the origin you are rotated, so that is w1 by modulus of w1. Okay, and you can definitely observe that it is rotated and both of the modulus values are equal, so you can cancel out these values, and from here you will get w1 is equal to z1 into e raised to the power pi by 2, and you can use the Euler notation, that is e raised to the power. Okay, so what is the Euler notation, that is e to the power I theta is equal to iota sine theta plus of cos theta. Okay, so that is equal to iota sine theta plus cos theta. Okay, similarly, sorry, I missed an iota over here. Okay, so just need to multiply with, so you can definitely do like this particular fashion. Let me check for the results again, and that is z1 into e to the power iota pi by 2. Okay, iota 3 5. So that's a mistake that I wrote over here, that is whenever you multiply you just need to multiply with iota. Okay, I forgot to mention over here, that is iota over here and iota, so that is you just need to multiply e to the power iota 5. Okay, so the angle which you need to rotate is basically e to the power iota 5. So don't get me wrong. Okay, just I wrote this thing, I forgot to write the iota value. So definitely an iota pi by 2, and if you put theta is equal to pi by 2, you will get this value as iota, and this particular value as 0. So therefore this value will be equal to, this particular value will be equal to iota, that is z1 into iota. So z1 is basically 5 plus 4 iota into iota is basically equal to minus 4 plus of 5 iota, that is basically w1. And since you got w1, you can similar fashion you can obtain w2, and w2 is obtained by z2 into e to the power I pi by 2, but it is in the anti-clockwise in the clockwise sense. So if you consider the anti-clockwise as a positive angle, okay, so since the rotation as by anti-clockwise is basically assumed to be positive, so this is anti-clockwise rotation is positive. Okay, positive for anti-clockwise rotation. Okay, anti-clockwise, so I'm writing anti-clock rotation is positive. Okay, anti-clock rotation, okay, it is positive, so anti-clock rotation is positive. Similarly clockwise rotation will be negative. Okay, so therefore here it will be negative sign, and similarly the value is equal to 3 plus, okay, 3 plus 5 iota, and if you multiply e to the power minus iota pi by 2, and that is equal to, that is basically equal to, it will be coming out as 5 minus 3 iota, because e to the power minus iota pi by 2 is equal to minus of iota. Okay, minus iota, and that is equal to 5 minus 3 iota. Now I have to look for the value of w1 minus w2. Okay, so if you consider this value w1 minus w2, you will basically get it as, so if you can do this on yourself, that is minus 4 plus of iota minus 5 minus 3 iota, this value will be equal to minus 9. Okay, minus 9 plus of 8 times of iota. Now I have to look for the argument. what is the value of the argument? Argument is basically of tan inverse of y by x, the imaginary part of a complex number divided by real part of a complex number. That basically gives the argument of the complex number z. And from here you can definitely find the argument of w1 minus w2 is equal to tan inverse of 8 by minus of 8 by 9. And since we cannot write, since the principal argument is basically the such value of theta which basically lies between 0 and pi, sorry, the basically principal argument belongs from minus pi to pi, with pi actually argument of any complex number basically belongs to minus pi to pi, and pi in closed and minus pi in open. So this is the actually the principal range of argument of z. So you can, if you have to write the argument over here, you can do this as minus of, and then you can use the principle of ITF or properties of ITF, tan inverse of minus of x is equal to minus of tan inverse of x, and that is minus of tan inverse of 8 by 9. And with this the answer, but since minus of tan inverse of 8 by 9 basically doesn't simply come in this particular range, so I will do this, and for making it coming in this particular range, I will just add up. So since this particular value, if you look at this particular value, minus of or tan inverse of minus of 8 by 9, this particular value actually comes in the third quadrant. Okay, so since this particular value is a third quadrant, principal argument then becomes pi plus, okay, since it is in the third quadrant, the principal argument becomes pi plus minus of tan inverse of 8 by 9, and that will give you the answer that is equal to pi minus tan inverse of 8 by 9. Okay, pi minus tan inverse of 8 by 9. Alright, so I hope you have got this particular value, because I have to look for only the principal argument, but since this particular value actually lies in the third quadrant, okay, therefore it cannot be possible that the principal argument is in the third quadrant. That means you have to look for the value which is basically of this particular interval, and that is basically possible only if you like pi minus the required angle. So if you add a pi to that, then you basically get the required value. I hope this particular problem is clear. Alright, so with this, let us, and with this the option will be basically, the correct option will be basically equal to option number C. I hope you have done this particular problem and you got to the option number C as the right answer. Okay, and with this you basically grade yourself. Let us move to the next problem. Alright, the next problem is again of a set, given set, where for complex number x is equal to z is equal to x plus iota y, such that 2 times of z minus 3 times of iota divided by 4 times of z plus 2 times of iota is a real number. Okay, now there is a very important type of problems that are basically involving, given a complex number of a different types, they are basically asking you whether it is purely real and purely imaginary, and based on that they basically have to calculate for the values, for different values of the like variable parameters. Okay, so you can definitely understand that these questions are actually important. You can find these types of problems actually get repeated in many times in the examinations. Even if you look at the JEE MAINS advanced paper of 2023, you can find the similar types of question was actually asked, and it was said that this given complex number is purely imaginary, and then you have to look for the condition of theta, and based on theta you basically have to calculate the values of the tan theta, sin theta and cos theta relatively. Okay, so you can understand these questions are actually important. So it is said that z is equal to x plus iota y, and it is said that this particular complex number, that is, so let me write this complex number as z1, that is 2 times of z minus 3 iota whole divided by 4 times of z plus of 2 iota is actually a real number. Okay, is a real number. So if it is a real number, now there comes a very important implication that whenever a complex number is real, okay, so if I say z is purely real, you don't need to just remember this. Okay, you can definitely solve this by putting z is equal to x plus iy and then getting the real part and equating the imaginary part is equal to 0. But you can definitely also, but if you know, if for the sake of can, okay, you can understand this as, okay, so if I subtract z minus z bar, so this particular value will imply that imaginary part, and if I equal it to 0, that is basically z is purely real. And similarly, z is purely imaginary, then you can definitely do this. Okay, that is z plus z bar, that is a real part of the z, and that will basically be equal to 0. So for purely imaginary, the real part will be equal to 0, and for purely purely real, the imaginary part will be equal to 0. So that is z is equal to z bar, and for purely imaginary, z is equal to minus of z bar. I hope you will remember these results. Okay, these results are not very important, but many times in the equation that this particular results will be directly given, and you basically need to look for it. Also, without knowing the result, you can definitely solve this particular problem. Then I can write z1 as 2 times of x plus iota y minus 3 iota whole divided by 4 into x plus iota y, okay, plus of 2 times of iota. And with this you can definitely solve this as, so you can definitely write this as 2x plus iota times of 2y minus 3 whole divided by 4x plus iota times of 4y plus 2. Okay, you will get the complex number z1 something like this. Now let us multiply this particular complex number, or you can perform the division by multiplying with its conjugate. So let us do so. That is, with multiplying with its conjugate, what I will basically get, the denominator part will be 4x square plus 4y plus of 2 plus of 2 whole square. Okay, so the imagine for the denominator part will become 4y plus 2 whole square, and the numerator part will become 4x minus, okay, so sorry, not 4x, I am looking for the firstly the real part. Okay, firstly get to the real part and then equate the imaginary part equal to 0. So let us get the entire complex number. Okay, so this will be firstly equal to 8x square, okay, plus 2y minus 3 whole time into 4y plus of 2. Okay, and similarly the imaginary part will be equal to iota times of 4x into 2y minus 3 minus of 2x into 4y plus of 2. Okay, so this will be the imaginary part, okay, of the numerator portion. So that's basically performed by just multiplying the denominator and the numerator by its conjugate, and with this you can definitely get the imaginary part. So if it is totally real, because since the z1 is real, z1 is purely real, then I can write that the imaginary part of z1 complex number is equal to 0. And with this you will find that if I equate this complex number, the imaginary part of this complex number equal to 0, you will get the relation as 4x into 2y minus 3 minus of 2x into 4y plus 2 whole divided by 4x whole square plus 4y plus 2 whole square is equal to 0. Now if it is equal to 0, the numerator part will be definitely equal to 0, because denominator is not equal to 0, it is always a positive quantity, and the numerator, equating the numerator to 0, I will get it as 4x into 2y minus 3 is equal to 2x into 4y plus of 2. So from here you will get a relation, and you can do one important thing, that is taking 2x common. You can take this on this left hand side and take 2x common, and with this you will get this result as, so you can perform this result as 4y minus 6 minus of 4y minus of 2. Okay, so from here 4y and here 4y. Okay, this is minus 4y and this is plus of 4y minus 2 is equal to 0. So from here you will see that 4y and minus of 4y it cancel, and this will be equal to 2x into minus of it is equal to 0, and with this x is equal to 0. Okay, so the value of x is equal to 0. Now you need to look for, it is said that which of the following is not correct. So again I am saying in the question which of the following is not correct, then from here I can directly cancel that x is equal to 0 is a true value, so this cannot be an option. Now I have to look for the values. Okay, now it is said that, now again it is said in the problem that this particular number is a real number. That means, and also the denominator cannot be 0. So if you look at the denominator portion, that is 4x square plus 4y plus of 2 whole square is equal to 0. Now this cannot be equal to 0 for this complex number to be entirely real, or this division to be possible. And from here if you calculate this by putting x is equal to 0, and if you are calculating this, you will find that y is equal to minus of, y cannot be equal to minus of half. Therefore y cannot be equal to minus of half. And now if you put x is equal to 0 and y cannot be equal to minus of half, then the y plus y square is cannot be definitely equal to is equal to minus of 1 by 4. That means option number A is also a right answer. So this cannot be the answer to this particular problem, because the question is asking for the not correct option. Okay, because many times it is, instead of asking the correct answer, it is basically asks for the wrong answer. Therefore now again I can see that x is equal to 0, but y is not equal to half, minus of half. That means but it is in the option B. if you look at option B, it is said that x is equal to 0, but y is equal to minus half. So that cannot be possible. Y not equal to minus half is a possible case. That means option B is a incorrect option. Incorrect answer, and this will be the right answer to this particular question. And with this, the option number B is the right answer to this particular problem. I hope you have understood this particular problem and you have working out how to just solve this particular problem from this particular results. Okay, because in complex number questions you will mostly encounter these kinds of results where you basically solve for like correct and incorrect options. Okay, so this was very important problem. Okay, and similarly you will look for that there are similar kind of questions actually get repeated. So let us move to the next problem. So the next problem is basically again the similar kind of concepts, is again talking about like purely imaginary case. Okay, like the previous problem, it was asked for the purely real case, and similarly this problem calls for the purely imaginary case. Now let us understand how to solve this particular problem. So it is said that there is a complex number z is equal to x plus iota y, and it is said that the complex number, let us understand this complex number z1. So 2 times of z minus 3 iota divided by 2 times of z plus iota is purely real, imaginary. Okay, it is purely imaginary. That means the real part is equal to 0. So again, if I talk for real part, that is x plus x z bar is equal to 0. Okay, so similarly for this particular complex number z1 is purely imaginary. That means z1 plus z1 bar is equal to 0. So if I calculate that this particular result, so you can definitely solve this result. So from here, if I calculate the result, that is 2 times of z minus 3 iota divided by 2 times of z plus iota plus 2 times of plus, and if you know this particular result, that is, for example, if a complex number alpha and beta and taking the conjugate of the entire complex number is equal to alpha mod by beta bar. Okay, so therefore you can imply this same concept over here, and this will become 2 times of z bar plus of 3 iota. Okay, plus of 3 iota divided by 2 times of z bar minus of iota. Okay, so this value is equal to 0. Now let us solve and compute for this result. You can definitely solve this result by multiplying, that is 2 times of z whole square plus of 1 whole square, and if you cross multiply, this will be 2z minus 3 iota whole multiplied with 2z minus of iota, and plus of 2z bar plus of 3 iota multiplied with, okay, so this is z bar over here, and multiplied with 2z plus of iota, and this entire thing is equal to 0. That means the numerator part will be equal to 0. So if you solve for the numerator part, and the numerator part, if you definitely solve for this, and they will get 4 times of z bar, and that is basically mod of z bar, mod of z whole square. Okay, minus of 6 times of, and if you look for the part that is 3 times, that is this particular part, that is when you multiply, that is 6 times of iota z bar, and this will become iota times of 2 iota z. So if you multiply this is not bar. Okay, I'm just showing the multiplication, the value, how are you multiplying. Okay, then if you do so, then you will basically get this as 6 times of iota z bar, and that other will be 2 times of minus iota z and minus of 3. Okay, so this is the first bracket, plus the second one is 4 times of mod of z bar whole square, mod of z whole square plus 6 times of iota z, and plus 2 times of iota z minus of 3 is equal to 0. So from here you can, if you simplify, the result will be 8 times of mod of z whole square minus of 4 times of iota z, and this will be, this particular value will get cancelled. Okay, if you look at this value and this value get cancelled, and similarly, okay, so yeah, so this value get cancels. Am I doing it right? Oh, sorry, I forgot to put the mod over there, and that's why I was getting wrong answers. Okay, so there is a bar over here. Okay, so that will make it 4 times of 4 iota z bar, okay, minus 4 iota z. So there is a problem that actually happens in examination situation. Okay, so in not do this particular problem, just have your patience and solve it correctly. Okay, because after all, solving the problem you get a different answer, that is a really a very big of a silly mistake. Okay, so definitely don't do the silly mistakes like writing a bar and missing out the bar, and definitely go on cancelling out, so you will get incorrect results. Okay, so you must mind that incorrect result, that whatever incorrect thing I'm doing also. Okay, so these are actually the incorrect thing that actually people or students tend to do in the examination. Okay, so you must mind this particular incorrect thing. Okay, so with this you will get the result something as this. Now let us put back z is equal to x plus iota y. and if you put the z into x plus iota by in this particular equation, you will get this as 8 times of x plus x square plus y square. Now minus of 4 iota, if you take minus of 4 iota common, and this will become z bar minus z. So z bar minus z is basically equal to, so you can definitely find out this is basically equal to x minus iota bar minus of x minus iota y. Okay, so here this particular value get cancelled, and minus 6 is equal to 0. So from here 8x square, so you will get the relation as 8 times of x square plus y square, okay, minus 8y minus, so here you will get as 8y minus of 8y, okay, and minus 6 is equal to 0. So you can simplify this as x square plus y square, so 4 times x square minus 4y minus 6 is equal to 0. And now it is said that in the problem it is given that x plus y square is equal to 0. So x plus y square is equal to 0. Okay, so you have to look for x plus y square. So in the problem it is given x plus y square is equal to 0. Okay, so it is in the problem it is given that x plus y square is equal to 0. So from here x is equal to minus of y square. Okay, minus of y square, and then if I put x is equal to minus of y square in this particular equation, I will get it as 4 times of y to the power 4 plus y square, okay, minus of 4y minus of 3 is equal to 0. So from here the resulting equation I will get it as 4 y to the power 4 plus y square minus y is equal to 3 by 4. Just I took 3 on the right hand side and divided by 4, so I will get y to the power 4 plus y square minus y is equal to 3 by 4. And what is asking the problem? It is asking the problem to find the value of y to the power 4 plus y square minus y, and you will get the value as 3 by 4. So with this option number C is the right answer to this particular problem. So you can look for it, that is the required value that was basically asking the problem. So you must know this particular approach, like how did I approach this particular problem. Instead of like ordinary approach values, that is instead of putting z is equal to x plus iota y and then dividing it and the division by like multiplying with this conjugate, I took a different step, and instead doing that I basically added z plus z bar equal to 0 for purely imaginary part, and that's how I got to the answer. So you can definitely keep in mind of this particular way of solving the problem. And similar problem was actually asked again and in different attempts, so you can understand that how important these types of problems actually are. So you can definitely solve this particular problem. So I will let this particular problem as a homework problem, okay, to all of you. So you can look for this is saying for the, you have to just look for the set A. The set A basically of all the theta values, okay. Now this was the similar kind of problem that was actually asked in JEE advanced also, okay, only the values were changed. So if you look at this theta value belonging to 0 to pi by 2 pi, sorry, it is saying that this particular complex number is purely imaginary. That means for this particular problem complex number, how to solve this particular complex number, you just take the complex number, multiply with its like divide it, like multiply it with its conjugate in the denominator and the numerator part, and definitely get to the complex number, then separate the imaginary and the real part and equate the real part to 0 and definitely get for the values of theta. So that will be the idea in this particular problem. So if you assume this particular complex number z, so what I will suggesting you that multiplying, that is 2 iota sine theta divided by 1 minus iota sine theta, okay, and if you multiply with this conjugate, okay, so you can find one similar video on that JEE advanced question solving of 2023 paper. The similar question I have already covered in a short video, okay. I will pin that short video in this particular description of this particular session, okay. I hope you can definitely check out that particular problem as well, and that is multiplied with sine theta. So if you do so, you'll get a complex number, and if you separate the real part and the imaginary part, and if then you equate the imaginary real part is equal to 0, and then you equate the real part of z is equal to 0, then you basically get the condition of theta. So there will be a trigonometric equation. So after all, this particular problem then becomes a trigonometric equation, and you have to look for all the sum of the elements in A. Alright, so I will be waiting for this particular answer in the comment section. Fairly simple problem, but actually very important problem, because this kind of problem actually get repeated in 2016 paper. If you look at the JEE Mains 2016 paper, you will find this type of similar problem was actually asked. Okay, and continuing the race forward, you will find it this type of problem was actually asked in 2018 also. 2019 you can find in different attempts as it was actually asked. So you can understand that how important these types of problems are actually. Okay, so with this, let us move to the next problem, and I hope you will do this particular problem on yourself with the idea that I have given to you. Okay, and come up with the answer in the comment section. I will be eagerly waiting for your comments. Let us move to the next problem, and the next problem is again a fairly simple problem. Okay, but still I took this particular problem. This problem says that there is a complex number, that is z is equal to alpha plus beta times of iota, and it is said that z plus 2 mod is equal to z plus 4 times of 1 plus iota. Again, it is for making you to solve the complex equations. Okay, so definitely, like, go on putting and solve the complex equation, you will basically get to the radical value, that is alpha plus 2 iota beta modulus is equal to alpha plus beta plus 4 iota. So if you solve this, this will be alpha plus 4 plus iota times of beta plus 4. But since this is a modulus value, so modulus value will always be a real number. That means beta plus 4 will be obviously 0, because for the correctness of this particular equation, the real parts will be equal to the real part, and that means the beta value is equal to minus of 4. So that is a very direct implication from here. And the rest one is basically alpha plus 4 is equal to square root of alpha plus 2 whole square plus beta square. So from here, if you square both the sides, you will get as alpha plus 4 whole square is equal to alpha plus 2 whole square plus beta whole square. Now beta value is already equal to minus 4, so you can directly write beta whole square is 16. So from here, if you solve the equation, alpha plus 4 whole square minus alpha plus 2 whole square is equal to 16, you will get the quadratic in alpha. So for, or you can definitely, if you see, this will not become quadratic alpha, because alpha square and alpha square will get cancelled. So you will get a linear equation in alpha, and if you look at the linear equation in alpha, the equation will be of this particular fashion, that is 4 alpha plus 4 plus 16 is equal to 16, and 16 and 16 get cancelled, and alpha will be basically equal to minus 1. So from here, alpha value will be equal to minus 1. So I can definitely, but it is asking the problem that I have to find the equation whose roots are alpha plus beta and alpha beta. So if you look at alpha plus beta value, the alpha plus beta value is equal to, so alpha plus beta value is equal to minus 3, and similarly alpha and to beta value is equal to, so beta is equal to minus 4, okay, and alpha is equal to minus 1. All right, sorry, very sorry, alpha is equal to 1. Okay, so there is a error from my side. Okay, so alpha value is equal to 1. So if you that's the wrong itself in my solving. Okay, so there is also 8 alpha over here. So if you solve them, then the value will be equal to 1. So alpha value is equal to 1. So beta, alpha plus beta is equal to minus 3, and alpha beta is equal to minus of 4. Okay, so alpha beta is equal to minus of 4. Now such a equation whose roots are alpha plus beta and alpha beta will of the format x square minus of minus, that is plus of 3x minus 4 is equal to 0. Okay, minus 4 is equal to 0, and okay, so the correct answer, okay. All right, very sorry. I just took the alpha beta as the roots, but instead the roots were alpha plus beta and alpha beta. Okay, so you have to just be fairly cautious over here. So these are the roots. Okay, rather alpha and beta as the roots. So I took alpha as a beta as the root. That's why I got different result. So if these are the roots, so sum of the roots will be is equal to minus of 7, that is x square plus 7, and the product of the root will be equal to 12. So it will be plus of 12, and that is equal to 0. So this is the quadratic equation whose roots are alpha plus beta. So his roots are actually alpha plus beta and alpha beta, that is minus 4 and minus 3. Okay, so with this, the correct answer to this particular problem will be option number D. I hope this particular problem is fairly simple and was actually pretty simple. Okay, but since this type of problem I actually asked in the questions paper, I definitely took out this particular problem, because this problem basically fairly focused upon solving the complex equation. So that is basically important. And with this, let us move to the next problem. So the next problem is again a fairly simple problem, and this problem actually talks about, okay, so if you try to understand, this says that if let a and b are not equal values, are two non-zero real numbers such that the number of the elements in the set, so there is a set which is given by x such that z belonging to a complex number, okay, complex number, where the condition is basically real part of az square plus bz is equal to small a, okay, and the real part of az plus bz square is equal to small b. So such a set of a z, that z belonging to a complex number, where these two conditions are actually implied, you have to look for that particular number of elements which are possible for this particular set. Okay, now this is a very important problem. Okay, if you look at these types of problems, again get repeated. So the conditions that you basically obtain from here, so let me put or assume z is equal to x plus iota y. Okay, so that is a let over here. So if I put z is equal to x plus iota y, first equation it is given as, so if I square the z square, it will be x square minus z square plus 2 times of iota times of xy. Okay, now the first problem it is asked is a z square plus bz. So if you solve this, you will find it as a times of x square minus y square plus of 2 times of iota xy, okay, plus b times of x plus iota y, okay, plus b times of x plus iota y. So if you simplify the real part and the imaginary part, this is a times of x square minus y square, okay, x square minus y square plus bx plus iota times of, okay, 2xy, okay, 2xy plus by. Okay, so that's the first complex number, and that value is equal to a, and a is a real number. Okay, a is a real number. That means this particular value will be equal to 0. Okay, so you have to equate the imaginary part equal to 0. So if you do so, you will get the equation as, so x square minus y square multiplied with a plus b times of x is equal to a, and the imaginary part is equal to 0. So if you solve this, this is x square minus y square plus, if you divide by a, so this is b by a x is equal to 1. Okay, so that's the first equation. And similarly, for the real next value or the next equation, that is real part of b times of z square plus a times of z is equal to b, so we'll also obtain fairly similar results. So you can definitely do that. Okay, so if you do that, there will be b times of x square minus y square plus a times of x plus iota times of 2xy plus b times of, plus this will become, sorry, a b is missing over here. Okay, so yeah, a b is missing over here, so let me write it correctly, and that is iota times of 2bxy plus 2bxy and plus ay, okay, equal to b. That means a real number, that means the imaginary part will be equal to 0. And similarly, I might have this mistake here, a will be there. Okay, so with this you can definitely write the equation, that is b. So if you divide by b square, okay, so if you divide by, not b square, b actually, okay, so if you divide the entire equation by equating the real part, and if you divide by b, the result will be again similar, that is x square minus y square plus a by b x is equal to 1. So that is the second equation. Okay, so that is the second equation. Now what I will do, I will see that x square minus y square is fairly common in both the equation. That means on subtracting equation 1 and 2, so I'm subtracting the second equation from the first equation, that is second minus first, so I will get the result as b by a minus a by b whole into x is equal to 0. Okay, so from here I'll get a result, that is b by a is equal to a by b, and this result will be equal to b square minus a square is equal to 0, and that will make a is equal to plus minus of b, or vice versa. You can definitely express by other than that. Okay, and it is said that a is not equal to b, that means a is equal to b is not value, then a is basically equal to minus of b. That is a possible case. Okay, that is a possible case, that is a is equal to minus of b, because a is equal to b is not allowed in the problem. So if I put a is equal to minus of b, okay, so if a is equal to minus of b, so from equation number 1, if I put a is equal to minus of b, I will get this as minus part. Okay, so minus of x, and when, so, and also other case will be possible case is equal to, that x is equal to 0. Okay, so value of x is equal to 0 and a is equal to minus b. So if x is equal to 0 and a is equal to minus b, so from first equation I will get this value as y square, sorry, minus of y square is equal to 1. So from here y is equal to iota. Okay, so y is equal to iota, but this is not a possible case because y should be a real number. Y should be a real number, so that is basically y belongs to a set phi. That means there is no possible solution for y. Okay, and there is no possible solution for y. Okay, now if I put a is equal to minus b, now when the value of a is equal to minus of b, the resulting equation on the first equation, you can see that this is basically x square minus y square minus x is equal to 1. Now if you look at this particular equation, now this particular equation has infinitely many solutions. Okay, for x and y belonging to real number, there can be infinitely many possible solutions because we are not bounded by the range of x and y. Okay, so there can be infinitely many possible solutions. So for this particular equation, there can be infinitely many solutions. So you can definitely say that for this particular problem, the number of elements in the set is basically infinite. The number of elements in the set is actually equal to infinite values. So the set value actually contain infinite number of values. Okay, with this, the option number D is the right answer to this particular problem. I hope you have understood this particular problem. Firstly, I took this case x is equal to 0, and then secondly I solved for the case a is equal to minus of b. Alright, so with this you will get the number of elements that is basically infinite. Okay, because there are infinitely many solutions. And with this I come to the end of this entire session for complex number. Alright, I hope you have enjoyed watching the entire solution of complex numbers and you have equally solved that particular questions before me. Alright, so that was actually important. So if you are asking me that what are the important topics that is basically important for complex numbers, I will recommend you just to practice the algebra of the complex number, important, and the geometry part of the complex number, as well as the questions which basically involves the properties of a complex number. So with these three topics, you can definitely assume that the questions will be definitely framed from these three topics as well. Alright, so I hope you have understood the chapter complex number easily and you are basically solving the questions before than me, and definitely comment me in the comment section how much grade are you actually getting out of, like, if there is 10 questions, so plus 40, and in case you do some negative marking, and definitely like explain me that also. Alright, and I have given two basically homework problems. I have already discussed the hint of the problem, but I will basically very open to discuss in the comment section, okay, about the answers and the solution. And also if you have any doubt regarding a preparation, definitely reach out to me through the comment section. And with this I come to the end, and thank you.